Good day everyone. Today I will be presenting the circuit design for our smart greenhouse system. This system is designed to monitor and display key environmental parameters such as temperature, humidity, soil moisture, and the presence of rain using Arduino Uno as the controller. Here is the circuit design of our system. It is powered by Arduino Uno, which serves as the brain of the system. There are 4 LCDs provides a summary display of the greenhouse system status. The second LCD shows the temperature reading. The third LCD displays soil moisture levels. The fourth LCD indicates the humidity. We have integrated multiple sensors and LEDs into our circuit. First one is our temperature sensor. If the temperature exceeds the threshold, the red LED lights up as a warning, and it will be shown on the LCD. Second one is the humidity sensor. It monitors air humidity levels. If the humidity goes beyond acceptable limits, the blue LED turns on. And it will also be shown on the LCD. The third one is our rain sensor. Our rain sensor detects the presence of rain and activates the yellow LED when it's detected. Currently, it is raining, and our drainage system motor will open. And the last but not least, we have our soil moisture sensor. It detects the moisture level in the soil. If it is below a critical level or up to critical level, the orange LED lights out. And it will also be shown on the LCD as a warning. The green indicator are when conditions are within safe and optimal levels, signaling that the greenhouse environment is ideal for plant growth. Here's how the system works. The sensor continuously sends data to the Arduino Uno. Arduino processes the data and updates the respective LED with real-time readings. If any parameters exceeds the threshold, its corresponding LED is activated to alert the user. As you can see here, all conditions are met and the green LED lights up. So now, let us move on to the coding part of this circuit. Next, we move on to our coding part. This system is designed to monitor environmental conditions and control greenhouse operations, ensuring optimal plant growth. Let's dive in. Our code is structured into several key sections. The first one is setup and initialization. sensor data collection, control logics, run fail safe mechanism, and display and feedback system. Each of these sections is carefully programmed to handle a specific aspect of the greenhouse operation. In the setup section, we define constants and pin assignments for all the components like LEDs, sensors, the pump, and the relay. For example, we have LED orange, monitors soil moisture warnings, and we use relay pin to control the fail-safe drain gate for heavy rain. We also initialize the LCD displays and servo motors. The reset actuators function ensures that all outputs start in their default state. Finally, a welcome message is displayed to confirm the system readiness. Then we have sensor data collection. The loop function reads real-time values from temperature, humidity, soil moisture, and rain sensors every 4 seconds, but only if the system is switched on. For instance, temperature is mapped to degrees Celsius using the analog pin temp sensor pin. Humidity and soil moisture are similarly processed. All sensor data is logged to the serial monitor for debugging and displayed on the LCDs. Moving on to control logic. The system responds dynamically to sensor reading. The first one is the temperature control. If the temperature drops below 18 degrees Celsius, the system closes the ventilation and activates a red LED with a warning on the LCD. If it exceeds 30 Celsius, the ventilation opens. For humidity control, for humidity below 30%, the irrigation pump activates, and a blue LED signals low humidity. High humidity triggers a warning, but does not activate the pump to avoid overwatering. This ensures an optimal environment is maintained for the plants. For the soil moisture sensor determines whether the pump should remain on or off. When soil moisture falls below 300, the pump activates, ensuring sufficient water supply. If it rises above 700, the system signals overwatering and pauses irrigation. By checking both soil moisture and humidity, the system prevents unnecessary water usage. One critical feature is the rain fail-safe mechanism. The rain sensor checks if the value exceeds 500, indicating heavy rain. If so, the system activates a buzzer, displays a rain alert, and opens the drain gate controlled by the relay. When the conditions normalize, the gate closes and the operations resume. This feature prevents waterlogging in the greenhouse during storms. The LCD monitors provide clear feedback for both operator and value system. Functions like display sensor data and display operator ensure that real-time updates, warnings, and actuator conditions are displayed clearly. For instance, display sensor data function formats sensor readings on the LCD. Warnings are displayed using the start warning function, accompanied by LEDs for visual alerts. The green LED acts as a system health indicator. If any warning is active, the green LED turns off. If no issues are detected, it stays on. Additionally, the reset actuators function ensures the system resets all actuators and clears the displays when the system is switched off. This guarantees safety and avoids potential error. In conclusion, this code provides an integrated solution for automating greenhouse operations. Thank you for your attention. That's all from our group. Thank you.